In this video, we're going to look at the heat required for phase changes. The first phase change will be taking ice and converting it into water. So taking solid water, going through the fusion or melting process to get to liquid water. If we reverse this, go from water to ice, this is freezing. The delta H for fusion of water is 6.01 kilojoules per mole. Notice that this is a molar quantity. The second phase that we'll be looking at is going from water to steam. So taking liquid water, going through the vaporization process to come up with gaseous water. If we reverse this, go from steam to water, we have condensation. The delta H for vaporization of water is 40.79 kilojoules per mole. Again, notice it's a molar quantity. If we think about the process of taking chilled ice all the way to heated steam, the first step is going to be heating up the ice to the melting point of water, 0 degrees Celsius. Once we're there, we're going to have to add more energy to the process to convert the solid water into liquid water, the heat of fusion. Then we'll heat the water up from 0 degrees Celsius to 100 degrees Celsius. And we'll have to do a vaporization water to go from 100 degrees Celsius water to 100 degrees Celsius steam. The last step is the heating of the steam. Let's look at a simple problem. How much energy is required to convert 25.0 grams of water at 25 degrees Celsius to steam at 110 degrees Celsius? We can break this one into 3 steps. First, heating of the water, 25 degrees Celsius to 100 degrees Celsius water. Vaporization of water, 100 degrees Celsius water to 100 degrees Celsius steam. And then the heating of the steam, 100 degrees Celsius steam to 110 degrees Celsius steam. First, heating water. We're going to use Q equals mass times the specific heat times the change in temperature. Mass in this case is going to be 25.0 grams. Specific heat of liquid water is 4.184 joules per gram degrees Celsius. The change in temperature is going to be 100 degrees Celsius minus 25 degrees Celsius, or 75 degrees Celsius. Plug those in for our equation, and we see that Q equals 25.0 grams multiplied by 4.184 joules per gram degrees Celsius times 75 degrees Celsius. Do our mathematics, and we see that Q is equal to 7,850 joules, or 7.85 kilojoules. Second step, vaporization of water. In this case, we're going to need to know the moles of water, not the grams. So therefore, we're going to take 25.0 grams multiplied by 1 mole over 18.02 grams, cancel out grams, and we get 1.39 moles. We can then plug that into the formula Q equals the number of moles times the enthalpy of vaporization, or N delta H vaporization. Plug those two numbers in and we see we get Q equals 1.39 moles times 40.79 kilojoules per mole. That gives us 56.6 kilojoules. The third step, heating of steam, again we use Q equals mass times specific heat times the change in temperature. Mass again is 25.0 grams. Specific heat, this case we need to be careful that we're using specific heat of gaseous water and not liquid water. This is 2.09 joules per gram degrees Celsius. And here our temperature change is going from 100 degrees to 110 degrees, so we see a change in temperature of 10 degrees Celsius. Plug that into our formula, Q equals 25.0 grams multiplied by 2.09 joules per gram degrees Celsius times 10 degrees. Grams and degrees Celsius cancel, giving us joules, so Q equals 523 joules, or 0.523 kilojoules. Now we have the 3 separate steps of the heating process, or how much energy has gone into the system. So we just have to add them up together. So total energy is going to be Q first step plus Q of the second step plus Q of the third step. That gives us 7.85 kilojoules plus 56.6 kilojoules plus 0.523 kilojoules. Therefore, our total energy is going to be 65.0 kilojoules. Now in this example, we only went through 3 of the processes: heating of the water, vaporization of the water, and then heating of steam. You can have up to 5 steps in most cases And of course, you can also have a sublimation process where you go from solid all the way to gas. These problems aren't difficult, but they do take practice. Practice and get confident.